So this is practice problems for 2.1. First thing we're going to do is write down the equations we're going to be using. And in the horizontal direction for the projectile problems, we're going to use Vx equals delta x over t. In the vertical direction, we've got delta y equals 1/2 via fy plus voy times time. You don't really use that one very much. I think that's a shady equation. It's true, but it's shady. Sometimes you have, or sometimes it's very useful, but most of the time it's shady. It's useful to keep track of everything, because at some point, on some problems, you may have both horizontal and vertical acceleration. Alright, you guys have all seen those before. I hope they look familiar at this point. Connor and Ben are going to joust their motorcycles because it just sounds fun. Connor starts from rest and accelerates at 2.6 meters per second squared. Ben moves at constant velocity of 14 meters per second. If they start 492 meters apart, how long does it take them to meet? Okay, so this is going to be a relative velocity problem. It's not projectiles yet. So let's write down what we know about each of them. So we know, what do we know about Connor? So his VO is going to be equal to 0. What else do we know? Acceleration is 2.6 meters per second squared. Do you know anything else about Connor? Definitely not. Alright. So Ben moves at constant velocity. So what do we know about him? So his V is just going to be 14 meters per second. And for him, we can use the equation V equals delta x over t. Alright. Do we know enough for either of them to make any kind of progress in solving for anything? Nope. Alright. So we also have overall. What do we know? So how are delta x for Ben and delta x for Connor going to be related? They're not equal. Yep. So delta x for Connor plus delta x for Ben equals 492 meters. Does that make sense to everybody? And we also know that the time for Connor and the time for Ben are equal, like they're traveling for the same amount of time. Okay, so what do we think we're going to have to do here? So we have to substitute into this, right? Alright, so for Connor, we'd like to use initial velocity acceleration and probably have time in it since we know they're equal and we're looking for time. So the equation has delta x equals something with initial velocity, acceleration, and time. But we're looking for time. So we'd like to have it in the equation. So we can use delta x equals VOT plus 1/2 AT squared. That way we have time, then we have initial velocity, we have acceleration. And for Ben, we're just going to rearrange the Vx equals delta x over t to get delta x equals Vt. Everybody okay so far with this? Okay. Yep. So does everybody understand how I got from here to there? Yep, they both equal distance. I'm going to write these over here. Delta x for Connor equals VOT plus 1/2 AT squared, and delta X for Ben equals VT. And the T's are the same. Alright. Yes. Because they both start at the same time. And they're both going to meet at the same time. Alright. So now we're going to substitute in. This ends up being 0 plus 1/2 times 2.6 t squared plus 14 t equals 492 meters. Alright, so what are we going to have to do to solve that equation right there, since we have a t and a t squared? Quadratic formula, right? So we can't do this one without it. Do 1.3 t squared plus 14t minus 492 meters equals 0. Alright, so when you solve for time, you get a negative number probably and 14.8 seconds. So that's our answer. Any questions over that one? I'll show you later, Connor. So this is kind of one of the problems that you're going to need to be able to do. I promise this is going to keep coming up over and over again. You're going to have to know how to do that too. But this is like one that appears a lot. So a projectile is launched horizontally from a height of 29 meters with initial velocity of 35 meters per second. Then Quentin was mauled by a polar bear. How far horizontally does the projectile travel? Okay. So what do we know in the horizontal direction? Yep. So initial velocity, so Vx is going to be 35 meters per second. Do you know anything else in the horizontal direction? Nope. We know we're looking for delta x though in the horizontal direction. In the vertical direction, what do we know? Yep. So delta y is positive or negative 29. Negative because it's going to be falling that far. So if we negative 29 meters. What else do we know? Initial velocity is 0. So initial velocity in the y direction is 0 because it's thrown horizontally. What else do we know in the vertical direction? Yep. So g is equal to negative 9.8 meters per second squared. Yep. And so we're going to solve for time here and use that time, the horizontal stuff, to solve for delta x. So we're going to do delta y equals VOY t plus 1/2 gt squared. This equation is used a lot in these projectile problems, so you see yourself using this one over and over again. So we get negative 29 equals 0 plus 1/2 times negative 9.8 times t squared. And what do we get for our time? .43 seconds. So that's how long it was in the air for. Now we use Vx equals delta x over t. Vx is 35 equals delta x over 2.43. And what does delta x equal? 85.05 meters. So that's how far from the base of the cliff it landed. Any questions on that one? Nora throws Allie horizontally from a cliff 25 meters high with a velocity of 50 meters per second, which is pretty fast. What is the overall velocity Allie hits the ground with? So we have to include angle as well as the speed here. So, alright, what do we know about Allie in the horizontal direction? How fast is she moving horizontally initially? 50 meters per second. She's going to be moving that the whole way, so we're just going to say Vx equals 50 meters per second. And that's all we know, right?
No, we know how high the cliff is.
That's vertical.
That's in the vertical direction.
But he said that's all we know generally.
So what do we know in the vertical direction then, Connor?
We know that the cliff is 25 meters high.
So what's our delta y?
Negative 25 meters.
25 meters. We know g is equal to negative 9.8 meters per second squared. And we know her initial vertical velocity is 0. So in order to find the overall speed she hit the ground with, we need to find at the end that part of that triangle and that angle right there. So this side's going to be VFY. This side's going to be VX. So we already have VX. So if we can find VFY, then we can use that triangle right there to find how fast she hit the ground with.
What? Can you explain that again?
Sure, let me grab my... So we're going to use this information to find VFY. We have VX as 50. And then we're going to use Pythagorean theorem to solve for that question mark side, which is how fast she hit the ground overall. And then probably tangent to solve for the angle right there. Alright, so what equation can we use to solve for VFY here? Third one, yep, so fourth one, VFY squared equals VOY squared plus 2G delta Y. So it equals 0 plus 2 times negative 9.8 times negative 25. And what does VFY equal? Yep, it ends up equaling negative 22.1, because when you take the square root, it's plus or minus. Any questions on that one? Alright, and now we're going to do Pythagorean theorem with that triangle over there. So we're going to do 22.1 squared plus 50 squared equals question mark squared. Supposed to call that VF, but and so what is the overall speed it hits the ground with? 54.67 meters per second. So that's how fast Allie hit the ground. Then I need to figure out what angle. So we're going to use tangent because we have the two sides there. Let's say tangent theta equals VFY is opposite over adjacent is VX. So then we get theta equals tangent to the negative 1 of VFY, which is 22.1.
So you make that positive.
Yeah, do you make the 20?
You probably want to make it positive because when we're looking at this triangle, to find that angle, we want to have this side be positive because we're not really talking about direction there. We're talking about the triangle itself.
And would the final velocity negative?
This-
The hypotenuse.
That you're not going to make negative.
You don't make it.
Nope. So what's our angle? 23.8 degrees. So you hit the ground going 54.6 meters per second at an angle of 23 degrees above the horizontal or above the ground. Questions on that one? Last one we'll do together here. Projectile is launched horizontally from a cliff 11 meters tall with an initial velocity of 25 meters per second. A 3.2 meter high wall is located 12.6 meters away from the cliff. How high above or below the wall does the projectile travel? So this one helps to draw a picture on. So there's our cliff. There's our wall. So it's going to travel like that, right? And we're looking for that distance. So this right here is 3.2 meters. And what is this going to be in terms of a variable we've had, that top part right there? what variable would this be in our equations?
From there to the top.
From there to there. It's probably delta y or delta x since it's a distance. Delta y. So that would be delta y right there. That's how far it fell. And we want to figure out how far it fell when it was at the wall to figure out how high above or below the wall it went. So what are these three things going to add up to? 11 meters. So it's going to be 11 meters equals 3.2 plus question mark. And then delta y, we usually have that be negative, right? And when we find it, it's going to fall that far, so we'll say minus delta y, and that'll end up adding what the absolute value of delta y is. So if we can find delta y, then we can find that question mark distance, how high it went above the wall. Does that make sense to everybody? Alright, so what do we know in the horizontal direction on this one?
Well, the wall is 12.6 meters away.
Yep, so delta x for this one is going to be 12.6 meters. What else do we know in the x direction? Yep, so velocity in the x direction is 25 meters per second. And what do we know in the vertical direction? So you know VO is 0. G is negative 9.8. We don't know delta y. We're not going to use 11 because we just want the delta y when it gets to the wall. So not when it's gone all the way down. So that's all we know in the vertical direction. Because we're looking for the delta y when it's at the wall. So it won't have gone all the way to the ground yet. It's just going to have gone part of the way. So we can't use 11 for the delta y. So what are we going to have to do here? Because we're looking for like that distance right there at the wall, and that's not going to be 11 minus 3.2. That 11 minus 3.2 would be that whole thing right there. So that would be like when I got to this point. Alright, so we're going to find time in the horizontal direction, then use that time in the vertical direction to find delta y. So we have delta y that we can solve for question mark.
Oh, because it would be the time.
Yep.
That's right by, okay.
So we're going to say Vx equals delta x over t, and we get 25 meters per second equals 12.6 meters over time. And what do we get for our time there? 0.5 seconds. So that's our time over here too, is 0.5 seconds. And now what equation can we use to find delta y? Yep. Delta y equals VOYT plus 1/2 GT squared. So delta y equals 0 plus 1/2 times negative 9.8 times 0.5 squared. And what do we get for delta y? Negative 1.23 meters. So that's how far it fell. So now I say 11 meters equals 3.2 plus that question mark distance minus negative 1.23 meters. And that just cancels out and become plus. So how far above the wall did it travel?
Uh, 6.57.
6.57 meters above the wall. So that's the answer. Any questions on that one?